This is Design Safe Radio, where natural hazards researchers strive to make our society more resilient to everything nature throws at us.
So you've been working on from now, this is a common way that from NICE and now NERI, from seismic and wind and water, moving from calculation to test to discovery to subsystems and engineering type tests to back up to full scale systems. What are some of those other research projects that you found since those days at Buffalo that are really interesting?
Well, there's been a lot. I gave you a little bit of the work that we did on high strength steel with cars. And so that was a large collaboration with NSF, with American Iron Steel Institute and other producers to look at how could we take some of these sheet steels that have performance that are way beyond anything we're using in construction today, turn them into structural members and figure out how to optimize them.
Cool.
So that led to some changes in the standards that engineers can use and a nice body of work around really improving the what advanced high strength sheet steels. So that was a lot of fun. That was experiments and modeling, and that's a common for me. These days, we also, in collaboration with the American Institute of Steel Construction, with the Pankow Foundation, the Steel Tech Institute, and other friends, are looking at a bunch of lightweight floor systems. Some for like commercial scale that are all steel, some that like shorter spans, commercial or residential, but 10, 12, 14-foot spans, and all non-proprietary. So it's just been a really nice collaboration with a bunch of people to look at if I'm going to use steel because of its high recyclability content, but I need to get around some of these other challenges with low mass. Maybe I've got vibrations or acoustic concerns, whatever. How do I do that to create sort of new types of structural systems? And then the biggest one is our high-rise version of cold form steel, right? So that's leading to what was CFS NERI work and what we call CFS 10, where we'll talk more about that. But
yeah, we'll get to that.
That's
in a minute
super
here.
exciting.
Yeah, I'm really excited to talk about that. But first, are there any misconceptions out there about cold form steel or CFS buildings? Like anything that if there's somebody from the building industry or researchers or just general public should know about CFS and especially your CFS Research Consortium?
Yeah, I mean, I think for most structural engineers that have cut their teeth and spend their time specifying structural steel and reinforced concrete, CFS looks just crazy. It's just too thin. They can't sort of conceptualize that they should be designing large structures out of that. I might have a different perspective, having spent a career taking small 2x4 members and seeing them fail at 80,000 pounds, in a rig and things like that, right? So it's different if you've lived it and you see deformations. This is the big thing with cold form steel. Local buckling is not the end of the game, so you can see visibly see deformations and still have half or three-quarters of the capacity left before you top out the load.
Wow.
It's very different. So when we train structural engineers, we always teach them this word buckling. And we teach buckling equals failure. Buckling is a problem. That's not how automotive, aircraft, space engineers learn about buckling. That's just this interesting deformation pattern that shows up. Same for cold form steel. And so that sort of getting over the hurdle of working in a thin structure and dealing with some of the deformations that you see at service level that don't really correlate to strength is different for structural engineers, and probably the biggest challenge to get people interested and used to using it.
Yeah, well, and not just the engineers, but then the end user as well. Of like, is that supposed to happen?
Sure, right. Although as is most of the case with structural engineering, we're behind other things or whatever, so you don't get to view all the magic.
Yeah, which is sometimes a shame because the magic is
very cool, right? Yeah, but I mean, we're engineer nerds, so that's a little bit, our definition of cool may not be widely accepted.
Yeah. As I keep reminding people, like, if you ever think I'm too cool for anything, I've never literally been cool enough for anything.
Yeah, that doesn't exist.
So yeah, it's because structural engineers, we're behind the scenes a lot, but some buildings though, you'll have the structure exposed
Actually, the reason I fell in love with earthquake engineering as a student, even though I grew up in the Midwest, was because the structure is so prominent. I mean, like there's you can tell when you're someplace where earthquakes are important because suddenly the buildings look different, right?
Yeah.
And if you're a structural engineer and you start seeing all that bracing and all these hold downs and like different elements that you never see back at home, you're like, oh, what are these guys? What are they doing
Hmm.
or whatever? And like, the engineer that did this, they must have really, be working on something. And so it's a visceral to me, reaction. I also think that's why you find, in earthquake country and in cultures that have a lot of earthquakes, a different sort of relationship with structural engineers, right? It's a tighter connection.
Yeah. Yeah. I grew up in the Midwest too, and we moved out to Oregon a couple years ago. And like I was walking around the University of Oregon's night campus yesterday. And yeah, the structure is just completely different, a lot more open. You see the bracing.
It's exciting, right? You're like,
Thanks for listening to today's episode of Design Safe Radio. Be sure to like and subscribe on whatever platform you happen to be listening to this on. It really helps people find our show. Thanks to our amazing sponsors, the National Science Foundation and the NARI Network Coordination Office, which is award number 2129782. Big thank you to Marty LaChance, our guest booker and topic researcher extraordinaire, and Raquel Ruiz, who is our video and audio editor. I'm your host and NARI Facility Scheduling and Operations Coordinator, Dan Zahner. We'll see you in the next episode. Until then, stay resilient.